Hello everyone. Welcome to day two of Cisco SD-WAN training. Okay. In today's session, we are going to discuss about the authentication. Okay. So before before adding any devices into the SD-WAN, there are certain authentication that is being done between the controllers and the edge routers. Okay, so those are the authentication. What are those authentication? We will be looking at it today. Okay. So just to give you a brief idea, there are 6 types of authentications that are done before forming the entire SD-WAN fabric. Okay, the first authentication is between the vManage and vBond. Second is between the vSmart and vBond. Third is between the vManage and vSmart. Fourth, between the edge router and the vBond. Fifth, authentication is done between the edge router and vManage. And final authentication is done between the edge router and the vSmart. Okay. So yesterday we saw that we have done certain minimum configuration on the devices. We did the minimum configuration. We did minimum configuration on our vManage controller. Then we did the same minimum configuration on the vBond and on the vSmart. Okay. We also did the minimum configuration on the edge router. Now, what exactly happens after this minimum configuration is done? So right after doing the configuration on the controllers and the edge router, the authentication takes place. And this is the sequence in which the authentication takes place. All right. So let me walk you all through the authentication process. So we will first discuss about the authentication between the vManage and vBond, and we will see everything in detail, what happens between these authentication and what are the checks that are being done during this authentication and what exactly happens after the authentication. Okay. So let's say this is my vManage and this is my vBond. And this is the first authentication sequence that is happening. Okay. As soon as my vManage, as soon as my vManage is up, okay, as soon as it has the CLI minimum configuration on it, it starts looking for the vBond. And as soon as it finds that the vBond is up, the authentication starts. Now, during the authentication, what exactly happens? So my vManage will first send a client hello message to the vBond, to which my vBond will reply with hello verify request. My vManage will then again send a client hello message, to which the vBond will then respond with server hello. It will share its certificate and then it will send a server hello done message. Next, my vBond will also request from the vManage for the certificate. Now my vManage has received the certificate of my vBond. Now what my vManage will do is, my vManage will open that certificate and it will look for the serial number of the vBond. The second check it does is, it will look for the organization name of the vBond. The third check that it does is, it will look for the root CA details. Now the serial number, organization, and root CA, what are these? We have already discussed in our certificate session yesterday. So these are the 3 checks that my vManage will do before considering that this is the correct VBond that is trying to connect to me. Next, since over here my vBond has requested the vmanage for its certificate, my vmanage will here send the certificate. Now here my vBond will then open the certificate that is shared by the vmanage, and it will look for the organization details. Next, it will look for the root CA details. These are the only two checks that my vBond does during authentication with the vmanage. Now, when the vBond checks that the organization name is correct and the root CA details is correct and the certificate that is signed is correct, then the authentication is completed. The finish message will be sent between each other. And then what happens next is my vmanage, now that it has authenticated the vBond, it will share the serial.viptela file that contains the list of entire purchase devices. My vmanage will share this serial viptela file with vBond. Now, with this, my vBond knows all the devices that are purchased by my organization and the devices that can be added to the SD-WAN fabric. Remember, we discussed that vBond is the first point of contact to any of the routers or any of the controllers. This serial viptela file has to be with this vBond because it is the authenticator of the SD-WAN fabric. And that is the reason my vmanage is authenticating with the vBond first, and then it shares the serial viptela file. Now, what happens after the authentication? This serial viptela file, actually the vmanage and the vBond forms a control connection. Okay. These control connections are basically a tunnel, okay, which works on UDP port 12346. And under this control connection, under this tunnel, this serial viptela file is shared. So if there is any hacker in the network that is trying to see what exactly is being shared between these two devices, it will not have any control on this file because it is being sent under a tunnel. Now, important question is, who is the initiator between these two? Whatever the packets are being sent between each other, who is the initiator of it? Okay, my vmanage will be the initiator of it. And why will my vmanage be initiator of it? Because if you remember, during the GUI and the CLI configuration, we have mentioned the vBond IP. And that is how my vmanage know who is the vBond and to which IP to reach. These are all the interview questions. Okay. When you go for a L3 round of interviews, these are the questions that are being asked. So what is the package sequence? Who is the initiator? What exactly is being checked before the authentication? These are what happens after the authentication. Okay. On which port does the control connections are formed? These are all the interview questions. Okay. So I believe we have understood how exactly the authentication between the vmanage and vBond is done. All right. With that, let me quickly go to the lab and show you all the packet capture of this. So if we see here, Look, my screen is visible to you. Can someone confirm in the chat? Can someone please confirm whether my screen is visible? All right, perfect. Thank you. Okay, so here if we see, this is my vmanage, okay, and this is my vbond. Now I have turned on my vbond, okay. I have turned on my vmanage, but my vbond is still off. Okay, now let us quickly do a packet capture on the vmanage and see what exactly is being done by the vmanage. I will go to capture, and if we see, that ETH0 is being used to connect to the vmanage. So I will do the packet capture on ETH0. Okay. So let's understand what this packet capture is trying to do, what my vmanage is trying to do. So if we see here, it is trying to look for 10.110.1.11. It is trying to look for 10.110.1.11. Now, what is this IP? So this is nothing but the IP of my vbond. And if you see, if we go back to our diagram, if we go back to our topology, we see that my vmanage is up, vsmart is up. Apart from that, my edge routers are up. The only thing that is down is my vbond. And even though everything is up apart from the vbond, it is not forming any of the control connections. Now, let me open the vmanage. See, there are no control connections. The only control connection is it is trying to form is with the vbond, and that is also not in the up state. Now, what are these control connections? These control connections are nothing but whenever the authentication is completed between the vmanage and vbond, they will form a control connection with each other, and any communication that is being done between those two controllers or between the edge routers and the controllers are done under this control connection. This is nothing but a secure tunnel. So we see there are no control connections. Now what I will do is I will go ahead and turn this vbond on, and after that we will also verify the packet capture and see what exactly happens. So I've turned on this vbond. Now I will go to the Wireshark. I will filter out the IP address. We will wait for the vbond to come up, and then we will see what exactly is happening. And now we see the client hello message over here. Right. I will stop the capture now and we will see what has happened. Okay. Here we see that 10.1101.10, which is nothing but my vmanage, has sent a client hello message to the vbond, to which my vbond, which is 10.1101.11, has sent a server hello and the certificate request, certificate details to the vmanage. After that, in the third packet, we see that the vmanage has sent the certificate to the vbond. And once all of them have, both the controllers have verified that the other controller is legitimate, we see that the application is being sent, and that is where the finish packet is. Now let's open this packet and understand what exactly is happening between them. So what I will do is, this is the packet that is sent from the vmanage to the vbond. Apart from that, let's first look at the packet sent from the vbond itself. So here we have a certificate that is sent from the vbond and it is sent to the vmanage. Next, I will try to review the certificate. So if I go and dig into the certificate, this fragmented one. These are the basically certificate details. So if we look at this packet, we see that the certificate details over here, and we can see the organization name over here. Okay, so this is the organization name, CNH. In the certificate, we see that the CNH is mentioned, and this certificate is sent from the vmanage to the vbond, and this is what both the controllers verify. Apart from that, it also looks for the other details, wherein the identity of the devices, the validity of the devices, validity of the certificate. These are the other checks that it does. Okay, so this is the important thing that we have to understand, that the organization name is mentioned in the certificate. Apart from that, it also gives us the other details, the country, the state. So this is the country, India code. This is the city wherein this device is hosted. So this is all the details that it has in the certificate. So this is the details that the controllers verify before authenticating with each other and before forming the control connections. Let me show you one more thing. So since these controllers does not have The serial number, because these are the virtual devices, it has the chassis number. Okay, let me show you all the chassis number. So this is nothing but the chassis number EEABA982. And let us verify that in the certificate as well. So if we see here, this thing, EEBA982. So these are the chassis number. And if this is a physical device, this is where you will see the serial number instead of the chassis number. Now, if we go to the vManage, this is the certificate that is shared by my vManage. And let me verify the chassis number on the vManage. It is EEABA982 starting with and ending with 5D. And if we look here, it is starting with EEABA982 and ending with 5D. So now when my VBond sees all these details, it knows that this is the legitimate device, and only then it will form a control connection with the vManage. So this is how the checks are done on all the controllers. Okay, let us go ahead and see the next authentication sequence. So the next authentication sequence is between so the second authentication sequence is between the vSmart and the vBond. Let me just right. The second authentication sequence is between the vSmart and the vBond. And the packet exchange will be similar on both the vSmart and the vBond that which were there with the vManage. So the vSmart will first send a client hello message wherein to which the vBond will share a hello verify request. vSmart will again send a client hello packet to which the vBond will respond with server hello. It will share its certificate and then it will share server hello done. vBond will also request for the certificate of the vSmart. After receiving this certificate from the vBond, what vSmart will do is vSmart will look for the organization name. Secondly, it will look for the root CA details. Now, when it verifies that the organization name is correct in the certificate that is shared by vBond, it will look for the root CA details. And if the root CA details are correct, and if the signed certificate is valid, vSmart will authenticate this device and consider that the vBond is a legitimate device. And then it will share its own certificate to the vBond. Now what vBond will do is vBond will open this certificate and there are three checks that it will do. First, it will verify the serial number or chassis number of the device. Second, it will look for the organization name. Third, it will look for the root CA details. Now, the question is, why will the vBond look for the serial number details and why will not vSmart look for the serial number details? If you remember, in the first authentication between the vManage and the vBond, after they authenticated each other, vBond shared serial.viptela file with the vManage shared serial.viptela file with the vBond. And that is what the serial viptela file has all these details. Now that file is not shared with the vSmart, and hence it will not look for the serial number. Okay. Once the vBond sees that the serial number is correct, organization name is correct, root CA details are correct, a finished packet will be sent, and they will form a control connection with each other. And once this control connection is formed, what will vBond do is vBond will share the serial.viptela file with vSmart. This is how the authentication between the vSmart and vBond is done. Okay. Next, if there is any issue during the authentication, if let's say the organization name is not correct, this control connection will not be formed and the vBond will tear down the session. Similarly, if vSmart finds that the organization name of vBond is incorrect, it will tear down the connection. So this is the sequence 2 of the authentication. Let's go ahead and check for the sequence 3. And the packet exchange that we saw for the vManage and vBond, the authentication will all be the same for all the controllers. So that's the reason we are not verifying the packet exchange for these sequence. Let's see the authentication sequence 3. The authentication sequence 3 is between the vManage and vSmart. So between the vManage and vSmart, okay, one thing I missed between the vSmart and vBond is who will be the initiator of the session in case of vManage and in case of vSmart and vBond, who will be the initiator of this session? The initiator of this session will be the vSmart, and the reason behind that is during the minimum configuration, during the CLI configuration of this device, we have given the vBond IP address in the CLI configuration, and that is how the vSmart knows where to reach to the vBond. The next authentication sequence is between the vManage and the vBond. Sorry. The next authentication sequence is between the vManage and the vSmart. This is the third authentication sequence. So the first packet that is sent between these two controllers is the hello packet, client hello. And my vManage will share the client hello. The next, the vSmart will send a hello verify request. Again, my vManage will send a client hello to it, to which the vSmart will send a server hello, its certificate, and server hello done. And the vSmart will also request for the certificate of the vManage. Now, after receiving the certificate from the vSmart, vManage will open that certificate and look for serial number or chassis number. Second, it will look for organization name. Third, it will look for root CA details. The checks will be same on all the controllers. Now, once it has verified that this is the correct vSmart, it will share its certificate with the vSmart. vSmart will open this certificate and will do only two checks: organization name and root CA details. Now, again, why will vSmart not look for the serial number or chassis number? This is because the vManage has not sent any serial viptela file with this vSmart. Okay, and the serial viptela file is only available with the vmanage, and hence it will not look for the serial number details. Now, what will happen after the control connection? After they have verified each other, it will send a finish request. Okay. After the authentication is done between this vmanage, what will happen is, number one, my vmanage and vsmart will form a control connection. Second, my vmanage will push the configuration. If my vsmarts are conf if my vsmarts are designed to work on the device template, it will send the configuration to the vmanage. The vmanage will send the configuration to the vsmart. And third, if there are any localized policy, if there are any localized policies configured, then these localized policies will be sent from the, sorry, this, if there are any centralized policies configured, then these centralized policies will be pushed from the vmanage to the vsmart. And all of this will be done in the form of control connection. And who will be the initiator of this session? The initiator of this session will be the vmanage. Why? Because we have defined the IP address of the vsmart while we were doing the configuration via GUI. Let me show you where exactly we have mentioned this IP address. So Thala has asked for the certificate expiry date. Yes, it also does the certificate expiry date. That is what we discussed in the root CA. In the root CA, it also does the identity checks. And these identity checks also include the validation, the validity. Now let me share my screen and show you all where we have defined the IP address of the vSmart in the vManage. So if we go to the configuration, devices, And in the controllers section, this is where we have defined the IP addresses. Now, when we see over here, it is visible with the system IP. But when we add these devices, we add these devices with the VPN 0 IP address, the IP address through which it is reachable. So this is where we go and define the IP addresses, and that is how our vManage comes to know the IP address of the vBond and of the vSmart. Now I will quickly go ahead and show you all the control connections that are formed between the vManage and the vSmart. So earlier when we saw, there were no control connections. So if we see here, show control connections. If we see here, now it is forming the control connections with the vSmart and with the vBond. Earlier, when we tried to see the control connections, it was not showing any of the control connections. Now it is showing us the control connections because the authentication between these are already done. So this is the vSmart, this is the vBond, and these are the VHs. Now I have only two VHs on my network that are turned on, and hence I'm getting two of these VHs. Now we see the status of all the control connections are up. As we discussed earlier, it works on UDP 12346. And this is not the only port that it works on. It works on 12346, then 12356, 12366, 12376. Okay, it's better if I show you all. Okay, I will show you all the entire list of the ports that it works on. So there are approximately around 10 ports on which these control connections are formed. I will show you all the list of those 10 ports, and these are all UDP ports. Right? So this is how the control connection shows up. Now we will move ahead and see the authentication between the routers and the vManage and the controllers. So let me share my screen. Okay, so fourth authentication that is done is between the edge router and the vBond. We discussed earlier that the vBond is first point of contact for each and every devices. And that is the reason my edge router is first authenticating to the vBond. Even here as well, my edge router will share the client hello message, to which the vBond will share the server hello. It will then, okay, first it will share a hello verify request. Again, my edge router will share the client hello. to which the vBond will share server hello. It will share its certificate. It will share server hello done, and then it will request for its certificate. Now, upon receiving the certificate, what edge router will do is the edge router will verify the serial number. The edge router will verify the organization name and the root CA details. These are the only check that it does. Apart from that, what vBond does is vBond will also share an encrypted number. What it will does is it will just take a random number, it will encrypt it with its private key and share it with the edge router. Now what edge router has to do is edge router has to decrypt it with the public key of the vBond and share that number again with the vBond. Okay, so these details edge router has to share the certificate as well as the encrypted number. So along with the certificate, it will also share the encrypted number. The edge router will share the certificate and the encrypted number. Now what vBond will verify here is vBond will verify the serial number. Second, it will verify the organization name. Third, it will verify the root CA detail. And fourth, it will verify the number that it has shared earlier. If all these checks are correct, vBond will authenticate the edge router. And the finished packet will be sent. After authenticating, so before moving ahead, let's understand who has initiated the connection in this case. So in this case as well, my edge router will be the initiator. Now, why will this be the initiator? Because during the minimum CLI configuration, we have configured the vBond IP address. Now, what will happen after the authentication is completed? After the authentication is completed, vEdge will form a transient control connection with the vBond. Now, what is transient control connection? Transient control connection is nothing but this control connection will not be for a permanent basis. This will be on a temporary basis. Now, how long will this control connection be? This control connection will only last until the vBond shares the vSmart and the vManage details with the edge router. So after the authentication, the only role of the vBond is to share the vSmart and vManage IP details with the edge router. And that is how this edge routers come to know about the vSmart and vManage IP details, because these details are shared because my edge router now has to go and get authenticated to the vSmart and the vManage as well. So once the authentication is done, it will form a transient control connection. During this control connection, my vBond will share the vSmart and vManage IP details with the edge router, and then it will break down the connection. Now, this edge router, let's say my edge routers, let's say my edge router. Let's go here. This is the diagram. This is the lab on which we will be doing our practicals. So in this case, there are two links. The first one is the MPLS and second one is the internet. So in this case, what my vEdge will do is my edge router will authenticate using both the links. So authentication between the vBond and the edge router will be done twice. One through this link and the other one through this link. And both of them will be a transient control connection. And the authentication checks will be same on both the routers, on both the links. Now that with this, my edge router has been authenticated with the vBond. It has now received the vSmart and the vManage IP address. Now what will happen is my edge router will go and authenticate with the vManage. And this is the fifth authentication sequence. The packet exchange will be similar to the previous one. Edge router will send a client hello. vManage will send a hello verify request. Again, edge router will send the client hello, to which the vManage will send server hello, certificate, server hello done, and encrypted number. And it will also request for the certificate of the edge router. The checks on the edge routers will be similar to that were there on the vBond. It will check for the serial number or chassis number and the root CA details. After it has verified, here it will not look for the serial number and chassis details, but it will look for the organization name. Once it has checked these details, it has understood that this is the correct vManage it is trying to connect to, and then it will share its own certificate with the decrypted number. Now my vManage will do the same checks that vBond has done. It will look for the serial number of the device, organization name, root CA details, and the decrypted number. Once the authentication is done, a finish message will be sent and a permanent control connection will be formed between these two. Again, this will be on UDP port 12346. Okay. And after the authentication is completed, what my vManage will do is my vManage will firstly send the configuration to this edge router, and this configuration will be sent on netconf protocol over TCP port 830. This netconf will be sent under the control connections. So over this control connections, the netconf protocol will send its configuration. Apart from sending the configuration, the next thing my vManage will do is it will start checking for its reachability. Basically, it will start monitoring. Third, it will also send if there are any localized policies configured for this device. So these are the three things that are done after my vManage authenticates the edge route. That takes us to the last and final authentication sequence, which is the authentication between the vSmart and the edge router. Again, the authentication sequence will be same on the edge router and the vSmart. The edge router will first send a client hello. to which the vSmart will send a hello verify request. Edge router will again send a client hello, to which the vSmart will send a server hello, its certificate, server hello done, and the encrypted key. Then my edge router, the vSmart will also request for the certificate of the edge router. Upon receiving the certificate of the vSmart, edge router will look for the organization name and the CA details. If the details are correct, it will share its own certificate along with the decrypted key. My vSmart will then look for the serial number, organization name, root CA details, and the decrypted key. Once this is done, a finish message will be sent between each other. After that, a control connection will be formed between the edge router and the vSmart. Apart from this, it will also form a OMP pair between each other. Now, the control connections will be formed over UDP port 12346, and one OMP pair will be formed between the edge router and the vSmart under this control connection. Now, what will happen is, after they have formed a control connection in the OMP pair, my vSmart will send the routing details to this edge router. And it will also share any centralized policy if it is configured for this device. And both of this will be shared under a tunnel via OMP protocol. Apart from that, my edge router, let's say my edge router has two LAN subnets connected to it. One is x.x.x.x and the other one is y.y.y.y. My edge router has only let's say two WAN connections. So what my edge router will do after connecting is, my edge router will say that my x.x.x network is reachable via internet link as well as via MPLS link. My edge router will also say that my y.y network is also reachable via internet link and my MPLS link. Now vSmart, being the control plane, it will do all the calculation, and if there is any other edge router in the network, it will share those details with the other edge router, stating if you have to reach the x.x.x network, you can reach it via edge router 1 over internet link and over the MPLS link. It will share its service VPN details. So this is the last and the final authentication that takes place, and these are the details that is being sent. Now the question is, how many control connections will be formed? So if I have two links and I have one vSmart, in that case, two control connections will be formed with the vSmart, one with the internet link and the other one with the MPLS link. And how many OMP pairs will be formed? No matter how many WAN links you have, there will only be one OMP pairing between the edge router and the vSmart. Now this OMP pairing is formed using the system IP. Now what is this system IP? We have already discussed this during our last session. Okay, and since this system IP is being used to form the OMP pairing, there is only one system IP on each and every device, and that is the reason only one OMP pairing will be formed. Also important to note that this system IP is not routable on the network. If I have to take you all to the diagram, to the lab that we have. If we see here, each router has two links. Apart from that, there are two vSmarts. Now, the question is how many control connections will be formed on this router. So there will be total of 5 control connections, one with the vManage. Second, I will have two with vSmart 1, and third, I will have two with vSmart 2. Why will I have two with the vSmart 1? Because there are two WAN links. Similarly, why with two control connections with vSmart 2? Because I have two WAN links, and there will only be one OMP peering. One more point to note is when the control connections is formed between the the edge router and the vSmart. This edge router will share its LAN details with the vSmart, and it will share with both the vSmarts. Next, now if these are also authenticated, this edge router will also share its LAN details with both the vSmarts. Now vSmart will do all the calculations. The control plane quality calculations, all of these will be done with the vSmart, and the vSmart will share the routing details to BR Dubai, stating if you want to reach 172.16.71.network, you can reach it via MPLS link and via the internet link of BR London. So upon receiving these details from the vManage, if 172.16.61.0 has to reach 172.16.71.0, it will have two paths to reach. One via the MPLS, and the other one via the internet. And one important thing to remember is if it has two paths, by default, SD-WAN will do CCNP. By default, it will do equal cost load balancing. So let's do a quick revision. The first authentication is done between the vManage and the vBond. After the authentication, vManage will share the serial WebTela file with vBond. The second is between the vSmart and vBond. After the authentication between vSmart and vBond will share the serial WebTela file with vSmart. Next, the vManage and vSmart. After the authentication, vManage will share the configuration with the vSmart configuration, and if there are any centralized policy, it will share with the vSmart. Next, there will be multiple control connections between the vManage and the vBond, and this control connection depends upon the number of cores available on the vManage. Similarly, there will be multiple control connections between vSmart and vBond, and again it depends upon the number of cores present on the vSmart. Between vManage and vSmart, there will only be one control connections. So this is it about the controllers. Now coming to the edge router. Edge router, upon authentication with the between the edge router and the vBond, vBond will share the vSmart and the vManage details with the edge router, and there will be a transient control connection. Edge router will authenticate on both the WAN links. If it has two WAN links, it will authenticate using both the WAN links. If it has three WAN links, it will authenticate using all the three WAN links. And after the authentication and the vSmart details are shared, these control connections will be teared down. Next, between the edge router and the vManage, once the authentication is done between the edge router and the vManage will share the configuration on the router. Apart from sending the configuration, it will start monitoring. Apart from monitoring, it will also share if there are any localized policies configured. This configuration will be sent under the control connection over netconf protocol 830, and there will only be one control connection no matter how many WAN links it has. And these control connections will be formed on UDP 12346. After the authentication between edge routers, vSmart will send if there are any centralized policies configured for it. It will also, the vSmart will first share the centralized policy, then it will also share the service route details of other routers. Now this will be shared via OMP protocol. Now this OMP protocol runs under the control connections, and the number of control connections depends upon the number of WAN links and number of vSmarts. In case of two WAN links and two vSmarts, there will be 4 control connections with the vSmart for each edge routers. Now let's go ahead and see that on our lab. So this is my edge router. Now I have one WAN links at the moment. If you see here, I have only configured the internet one. I have not configured the MPLS one. And hence I will only see one control connections with the vManage, 2 control connections with the vSmart, and there are no control connections with the vBond. And if I do show control connection history, I will see that the control connection with the vBond is in tear down state. This tear down state is nothing but the transient control connection. This simply means that vBond has shared all the required details of vSmart and vManage with the edge router, and there is no requirement of this control connection anymore, and hence it is teared down. Apart from that, we will go ahead and see show OMP peers. Now here I see that there are two OMP peers, one with the vSmart 1 and other with the vSmart 2. This 99.99.99.12 is nothing but the system IP of my vSmart 1. Let me show that to you all. This is my vSmart 1. If we see here, if I see the system running configuration, the system IP of 99.99.99.12 is configured on vSmart 1. Similarly, I will go to vSmart 2. And I see that 99.99.99.13 is the system IP of my vSmart 2. And I see that the OMP peering is there on my vSmart 2 as well. And this OMP peering is with vSmart 1. This is my vSmart 1. This is my Dubai router. And this is my London router. So only one OMP peering is formed. The reason behind this OMP peering is there is only one system IP. There are no two system IPs, and hence there is only one OMP peering, no matter how many WAN links we have. Now, what is this RINS? So here we also see the state, which is up or down. We also see the site ID. So my Dubai site ID is 59, London site ID is 70. And the site ID of my vSmart is 10. Now, what is this RINS? R stands for received, I stands for installed, and S stands for sent. Next, I will do show OMP peers detail. If I do show OMP routes received, I will go to 99.99.99.60, which is nothing but my Dubai router, and I'll see which route I am receiving from it. This is the originator, this is the peer. Tab. Okay, so the routes that I'm receiving is 192.168.0.24 network. Okay, now what I will do is I will go ahead and turn this routers on. And my expectation is I should be receiving the routes via OMP peers on the vSmart. But for that, I will have to remove it from the. Okay, so this section we will see in the later part when we configure our own lab. We will see this in detail, how the routes are being sent. And for now, you only need to understand that after the authentication between the edge router and the vSmarts, these route details are sent to the vSmart, and vSmart will do all the calculation and will share the London route details back to Dubai router so that they can reach it, and the Dubai route details will be shared to the London route details. So this is all about the authentication that happens between the controllers. Let me show you all the port numbers that are being used for UDP. We'll stop this screen share. So these are the port details that are used for TCP, and these are the port details that are used for UDP. So it starts with 12346 and till 13046. All these ports are used to form control connections over UDP, and all of these ports are used to form control connections over TCP. By default, it works on UDP port, and all the clients that I've seen are only working on UDP port. The reason behind this is UDP is very faster as compared to TCP. And for all these control connections share, it has to be a fast convergence. And that is the reason by default it works on UDP. And Cisco also recommends to keep operating it on UDP. So guys, this is all about the authentication and its sequence. I will share this document with you all. You all can go through it, and just in case if you all have any queries, you all can reach out to me. Here it also mentions the netconf port that we discussed. Now let us discuss about the templates. So what is a template? Okay, by default, any SD-WAN device can be managed in two modes. The first one is a CLI mode, the one that we manage, the one that we configure the legacy routers. SD-WAN routers are capable of working on CLI mode as well. The next is the template mode. Now these templates are divided into two parts. One is a feature template and the other one is a device template. Now, what is a feature template? Let's take an example. I have a router over here, and this is the LAN network. This is the WAN network. Now, in order to make this router 100% working, what I will have to do is I'll have to configure a local credential. I will create a TechX credentials. I will create SNMP credentials, SNMP configuration. Fourth, I will do the LAN configuration. I will do the WAN configuration. In the LAN configuration, in the WAN configuration, I can have a BGP or any other routing protocol. Now, what is this? These are all blocks of configurations. These are all blocks of configuration. These blocks of configuration is nothing but a feature template. And when we club all these blocks of configuration into a one template, that becomes a device template. Let me take y'all to the vManage. If I go to configuration templates, this is this is the device template. This is the device template. And we see here that this template is attached to three devices. Now, if I click on these three devices, I will get to see which three devices are configured using this device template. Now, here I can see there are 10 feature templates attached to it. And if I go to the feature tab, I see there are multiple feature templates configured. These are nothing but block of configurations. If I have to give you an example of these block configuration over here, I have a AAA test. Now let's go to this AAA test and see what exactly is there in this AAA test. So in these AAA test, I have configured three usernames. First one is admin, second is test admin, and third is admin1. Now using this one feature template, I have configured three devices. Let's go ahead and see that on the routers as well. If I go to my Dubai router, if I do show run system AAA, I see the admin1, and test admin. Similarly, if I go to my router 2, which is my London router, over here as well, I see admin1, and test admin. So with this feature template, with this one feature template, I have configured two devices. And similarly, I can configure thousands of devices with this one feature template. Now let's say my organization has a compliance requirement stating that these credentials should be updated every 3 months. And let's say you have thousands of routers in your network. Now, to make the changes on these thousands of routers in legacy network, it will take a lot of human efforts and it is very time consuming. But with SD-WAN, it offers an inbuilt automation feature. What I will do is I will simply go to the feature template. Let me show that to you all. This is the feature template. I will simply go and let's say edit. I will edit the username of this test admin to admin user 1. I will also update the password. Next, what I will do is I will save it. I see here the admin user 1 is showing updated, but this is not yet pushed to the devices. I will do the configuration changes on the other user as well. I will update it to test admin user 1 and save the changes. Still, it has not been pushed to any of the routers. Now, when I click on update, it will tell me that these three devices, these three devices are these three devices will be updated as these three devices are being configured with this feature template. And we also get the name over here. Now, if I click on next, it will show the device details over here. It will give me the device template. So here only one device template is being updated because with this device template, I am configuring three devices. So under these one template, there are these three devices and these three devices will be updated with the configurations. Now, if I click on any of the device to see what exactly is being changed, we will get to see that as well. I will click on config difference, then side by side difference. I will scroll down. So over here, we see that earlier it was admin 1. We see that earlier it was admin 1. Now it has been updated to user admin 1. Similarly, earlier it was user test admin. Now it has been updated to test admin user 1. Now these configuration will be applied to all these three devices. Now let's say there were thousands of devices. With just few clicks, we can configure thousands of devices in within few minutes. This is the power of SD-WAN. Now, here we see that the color is yellow. Yellow meaning any config update. There will also be a red color we will see in a future labs. Red meaning those config is being removed. And there will also be a green color. Green color meaning the config is being added. So what I will do is I will push the configuration on all these three devices. I'll simply click on configure. Now it will tell me that if I click on OK, the configuration will be changed on these three devices. I will simply click on confirm configuration change on three devices and click on OK. Here we see that the configuration is being pushed. These devices, I have kept it down and hence it is still checking the configuration on it. Now we see that the device configuration is success on these two devices. Ignore this device because this device is down in my network. Now see that the configuration has been successfully pushed within few seconds. Now, even if there were thousands of devices, it won't take a lot of time. And within few clicks, these configurations will be pushed on all the routers. Now, what we will do is we will go ahead on the router and verify the changes, whether the changes has been reflected or not. We go to the Dubai router. I will go to my London router. Earlier on the Dubai router, I see that the user was admin, and there was a test admin and admin 1. What I will do is I will recheck the configuration. Now, here I see that the admin 1 is updated with admin user 1, and here test admin is updated with test admin user 1. Similarly, if I go to the London router, I see that the configuration has been updated to admin user 1 and the test admin user. So this is how we can use the SD-WAN technology to automate our configurations, and it really helps when there are a lot of devices in the network. So this was just a brief introduction about the templates. We will get into very much detail about these templates when we start building our lab. So guys, this is all about today's session. I will give you all the permissions to ask any queries if you all have. Guys, I've given you all the unmute permissions just in case if you all have any queries, you all can proceed with your queries.
Yeah, and good afternoon.
Yeah, hi.
Yeah, here in authentication process, we have a root here, right?
We have a
root CA.
correct.
Root CA certificate. So initially, from where exactly we are getting that root CA?
Root CA details, as we discussed earlier in yesterday's session. Okay, give me 1 second. I hope my screen is visible.
Yes.
Now, if your organization is using a enterprise root CA, we discussed this yesterday, right? If we have a enterprise root CA details, in that case, we will have to get the root CA chain from the certificate authority team that is there in my organization. And then this root CA details will be uploaded on all the controllers and all the routers. Apart from that, there are well-known root CAs. Okay, for these root CA comes inbuilt with the devices. So if I have to show you on the vManage, I will quickly go. Open my vManage. Show certificate root CA cert. Okay. When I put this command, I will get a lot of root CA details. This root CA details comes inbuilt. And if you are using enterprise root CA, you will have to add the root CA details in the controllers and on the edge routers. Does that clear your query, Krishna?
Yeah, but whatever the root CA is there, that is same root CA for edge routers, vBond, vSmart, whatever it is, right?
Yes,
That
yes,
authentication.
yes. Correct.
Okay, okay. No, because earlier when we are saying that authentication is happening from vManage to vBond, right? Some root CA communication is happening. Again, some edge router to vBond, again, root CA communication is happening, right? That already root CA is already recorded in the vBond, right? Then why it is
In the
again?
certificate. Yes, yes. The root CA details are present in the certificate and it is also present on the controllers.
Okay.
So if you are using Cisco as your root CA, in that case, you do not have to worry about all this. In case if you are using enterprise CA, all you have to do is you'll have to make sure that the root CA details are updated on all the controllers and the routers. Now, if you have to see whether the root CA details are updated or not, okay, so in that case, what we can do is I can go to the device or the controller and I will use show certificate root CA cert. Now, if I put this command, there are a lot of root CA details. Now, how do I identify which one is mine? So what you can do is simply show certificate root CA certs and you can enter your organization name or whatever subject is there in that root CA cert. So in my case, I have the subject as CNH. So if I do this command, I will get. Fair enough, Krishna?
Yeah, this is enterprise root certificate, you mean to say?
Yes, yes, yes. I showed yesterday, right? On the
Yeah,
vManage, we are using enterprise root CA. I showed you in the settings tab. I will show you once again.
got it. You can go ahead. Thank you.
Thank you.
Hi, this is Perne with you again. I have small questions. And by the way, Ayan, you mentioned that UDP port will be used for fast communication, right? However, for
Hmm.
the cybersecurity complaints perspective, there will be a big gap in between. How we can, fulfill in this way.
So in that case, the TC, let's say your organization doesn't want you to use UDP. In that case, there is an option to use TCP as well.
But the communication will be happen very slow.
Sorry?
Communication will be happen slow, right? The
Yeah, I mean,
controllers and the edge and
yes,
all.
yes, correct, correct. And also, see, these details, I mean, there is a control connections being formed. There is a tunnel being formed with this UDP port.
Mm,
So in that case, when the control connection is formed, all the data is being passed from this tunnel. In this tunnel, the credentials keeps changing after every certain set of time. Okay, and vSmart shares these details to, let's say I have a edge router 1 and I have a edge router 2. Now, the keys and the IP details for this edge router 1 and edge router 2. I mean, to form a tunnel between edge 1 and edge 2, there will be a certain IP details and the keys, right? These keys and IP details are shared by the vSmart to both the edge routers. Apart from that, it also keeps changing after every defined time. So the security concern is also out of the picture.
That means it was passing any communication will be under overlay.
Yes, yes, any communication is being done under this tunnel.
Okay. Okay, there will be a high secure.
Yeah, this will
But
this will be all
but the port is using UDP, but it will be
will be
the
secure.
communication
Yes,
is happening with the tunnel.
correct, correct.
Okay, thank you.
No problem.
Ian, actually, I would like to understand about this ECMP, which you mentioned about the two WAN links.
Yeah. So what question do you have with
No,
that?
I would like to understand like what basis does it choose the link actually? Is it like latency based or any other parameters being defined?
So by default,
Yeah,
if you have two paths,
two parts, yeah. WAN, I mean
okay?
IS, MPLS and internet, which is in the
Yes,
scenario which you mentioned actually.
yes. So if this subnet wants to reach to this subnet,
Correct.
by default, if you have not configured anything, one packet will be forwarded over here, other packet will be forwarded over here, no matter what is the SLA. If
You
this
mean to
link
say
has a
actually in the sense
if this link
latency?
has a packet, I'll come to your point. If this link, let's say my internet link has a packet loss of 2% and latency is 200 ms.
Hmm.
If you have not configured any SLA, by default, it will do load balancing. Now, if you have done any sort of SLA configuration, in that case, it will check the link performance before being forwarded. If both the links are meeting the requirement, it will do ECMP. If one of the link is not meeting the performance, it will remove it from the forwarding path.
Okay. In a sense of SLA, like what is the parameter being defined actually?
Packet loss,
Packet loss.
latency,
Okay,
jitter.
I
These
understand.
there are
Yeah, that
three
is what I was.
parameters you can mention.
Yeah, I understand. This, I mean, if we don't decide it, then it's going to be like 1-1, right?
Correct. One packet over here, second packet over here, third packet over here, fourth packet over here.
I understand. Okay, but if it's defined, then it's going to be only one path where it is going to take.
If it is defined, if you have defined the SLA and both the links are meeting the SLA, again it will do load balancing.
Like
If
1-1.
you want one,
Okay.
2, 3, 4. If you want only one link to forward the packet, then you have to define you do not have to define a SLA. You will have to define that this particular link should be preferred, and if this link goes down, this link should be preferred.
Okay, I understand. Yeah, thank you.
We will cover this in our practicals. Don't worry.
Okay, sure.
Yeah.
The small one again, Talha. Okay, what is OMP? You mentioned that, right? But I'm
Yeah.
not clear on that OMP. There is the first one. The second one, the infra
Hmm.
you mentioned is the 1:1 or 1:2, or how is the redundancy failover and all these areas, the branches office and all. And then you
So
said that it was communicated with the MPLS and then ISP connection, right? Then can you give
I'll
me the
come.
bit?
I'll first answer your first question with regards to the OMP. As of now, you only have to understand that there is a OMP pairing between the edge router and the vSmart. And this OMP pairing is formed using the system IP. Now, OMP itself is a very huge topic. Okay. And this we will have a separate single sessions for OMP. So for today, if you try to grasp all of this knowledge, you will get exhausted. So for today, only thing you have to understand is the OMP is formed between the vSmart and the edge router. It is formed using the system IP, and only one OMP pairing will be formed between the edge router and one vSmart. So if you have two vSmart, your edge router will form one
Could
with
you?
vSmart 1 and other one with vSmart 2. See, I will cover each and every topic in very detail. You just have to keep patience.
Yeah, sure. Sure. I'll be
I
waiting.
understand your curiosity, but then
Yeah,
see,
yeah.
if I start explaining you what is OMP on day two itself, there are very chances that you might not get anything of it. If you are capable of getting it, there are other audiences that might not be able to grasp it. So that is why I have decided that I'll go slow. I will clear each and every topic slowly so that every one of you all gets to know how exactly it is working. Fair enough, Kalam?
Hi, I
Yeah,
am.
yeah. Then the redundancy. I was asking 1:1 or how is the infra we can build it by the way.
1:1 with regards to what?
Redundancy, the failover. That means
Okay,
1:0 will be the single point of
Yeah,
approach,
single
and
point of
then
failure. Yeah, how we can
from
prevent,
what
like
perspective? Are you referring to
this
the vManage, vBond, or to the...
all infrastructure. I mean the edge. See, we are more
Okay,
focusing about the edge areas, right?
perfect.
Either
Correct.
Dubai and then
Correct.
London. Yeah. I'm sorry,
Correct.
I'm not I'm not taking a lot of time in that.
No, no, that
I
is
want to
fine.
clear it. Is
That is completely fine. So if you're talking about from the edge perspective, there is a lab wherein we will have add another router, and there are two redundancy mechanisms. Okay. The first one is TLOC extension. TLOC extension. And the other one that we will be using is VRRP. What we will do is we will add one more router over here. And the first TLOC one is the TLOC extension, wherein the ILL will be connected to this, the MPLS will be connected to this. Okay. Now each router will form control connection using MPLS as well as the internet, even though they have only one link connected to it. So this is TLOC extension, just to give you a brief. And this is one of the redundancy mechanism. The another redundancy mechanism is VRR. We will cover both of this topic during later part of the session, wherein I will also update the LAN.
okay, sure.
Answers your question?
Yeah. Thank you so much.
No problem.
Hi, I am. Just to add to that question, that was actually my question for redundancy. What about circuit links where you've got like resilient circuits? Sometimes you've got things like on-net or off-net circuits. Are you able to capture those as colors within SD-WAN?
With regards to on-net and off-net, see, we are using virtual routers over here as ISP. Okay, with regards to off-net is a ISP terminology. I mean,
Yes.
it has nothing to do with your SD-WAN technology. With your SD-WAN technology, the only thing that you should be bothered is about the reachability, whether it is on-net or whether it is off-net. All you have to do is your edge routers has to have the reachability till the controllers, no matter whether it is on-net or off-net.
Okay, so within SD-WAN, you're able to capture these as diverse circuit parts within SD-WAN when you're mapping your circuits or when you're onboarding your circuits. Is it possible?
Sorry, I didn't get you. Can you please come again?
Is it possible to capture for, let's say, a single internet circuit that goes to a location? You've got a single circuit.
I understand. You are talking about the breakout.
Yes, breakout.
All right. All right. So one link will be going towards your data center and other link will be going towards your internet directly. Correct? You're talking about this.
Yes.
Yeah, we will be covering that. Don't worry.
All right.
That is a direct internet access. Some people call it a local breakout.
Yeah.
Okay. Give me 1 second. Some people call it a local breakout. We have a separate session for these practicals. We will cover theory of it as well as the practical. Don't worry.
Thank you.
No problem.
Hello, Ayan. What is the TCC connection?
TCC connection, the transient control connection. Transient control connection. what is this transient control connection? Okay. So my edge routers will form a control connection with each of the controller. Okay. Now first it will form the control connection with the VBond. Each of the controllers has a predefined role. The role of this VBond is to provide the IP address of the vSmart and vManage to the edge router. Now, as soon as these IPs are shared with the edge router, there is no requirement for my edge router to have a control connection with this. Correct? So since there is no further requirement, it will break down the control connection with the VBond. That is what the transient control connection is. Now, it is one more point which is important to understand is if any router goes down and comes up again, for that matter, any controller goes down and comes up again, the authentication will be done again. So let's say my edge router goes down and comes up, it will first go to the VBond, then it will go to the vManage, then it will go to the vSmart and do the authentication and take the necessary details from them.
In that
Does
case,
that answer
will
your
be
question, Ravi?
yeah. In that case, will be packed for SLA or OLA if there is any
SLA or
controller.
no? So if the router itself is going down, the SLA itself is out of the picture, right? Your router itself is down. On what basis the SLA will be calculated?
For the connectivity between entire area. I mean, the branches and then communication with the
No,
SD-WAN,
but let's say your router itself has gone down. On
the
what basis
region.
the
That means
SLA?
that region is gone. There will be no SL account.
So SLA will be done on the WAN links, right?
Yes.
Now my router is down, meaning the interface itself is down. So there is no SLA in the picture.
Okay. Okay.
Hi,
Thank you.
hi, Ayan. So in the branch location, I can see edge router and another router.
Vaisak, 1 second. Harun has raised his hand just in case if he
Okay.
has.
Yes.
He was raised.
Okay. Yeah, my question is done. Okay.
Right. Yeah, Vaisak.
Yeah. So in the branch office, I can see we have edge router and another router, site router as well. So this
Yeah.
VEdge is another separate Cisco device, or if I have a C8200 device with the full SD-WAN support, we can use the same device, or it's a separate device, VEdge.
So VH is nothing but a Viptela device. Okay, and CS that you are referring to is a Cisco device. The functionality between both of them, how they operate is same. The only difference is between the commands. The commands are a bit different from what we use on the edge router. So for example, just to give you an example, okay, 1 second. So this is my okay. So this is my Viptela device. So where if I have to see the control connection, I do show control connections. Okay, and I get to see all the control connections. So if you are using a Cisco device, iOS XA device, in that case, the command that you will have to run is show SD-WAN control connections. So this is the only difference. Okay, so if I do here show BFD sessions, I see one BFD session. So this is for the Viptela device. Now, if you have to do it for the Cisco device, you will do show SD-WAN BFD sessions. So these are the only difference. Apart from that, the functionality is similar to what that is available for the edge route Viptela devices.
Okay. So when I'm just thinking about if I'm migrating a location and having a router is existing, so I need to place an extra edge router, right? Which with Tela device.
No. So can you please come again?
So if I'm migrating an existing location with a Cisco C8200 with the full SD-WAN capability, and then at that location I'm migrating to Viptela. So in that case, I need to add a vEdge with Viptela device, or we can migrate it with the same. That's my question earlier.
So if you have 8000 series router and you want to 8000 is your existing router, correct?
Yeah. So then I'm adding that complete infra towards the Viptela setup.
SD-WAN setup. Okay. So what you will have to do is, if you will have to see whether the model that you have is that a SD-WAN compatible. Okay. So if it is SD-WAN compatible, you will have to go to a specific iOS version. Okay. And then once you have enabled you have upgraded it to the iOS version, you will have to enable the controller mode on it.
Okay.
And once you have enabled it, you will do the minimum configuration. By doing the minimum configuration, it will reach to the vBond, vManage, vSmart, and then you will be able to manage it from the control.
Okay. So based on the license, and we can enable the mode for the router. Got it.
Yes. Any more queries, guys?
Oh, please go ahead. Thanks.
Ryan, you have any query?
Yes. So if you have got 5 branch routers, say in a single branch, you've got 5 vEdge routers, will they directly communicate with each other? Or how does the control plane traffic looks like for 5 routers if they want to talk to each other?
You mean 5 edge router at one location?
Yes. So in traditional, like you used to have like 3 or 4 routers at a certain location running OSPF, and then one router communicates to ISP using BGP. In this case, how will that look like? Will the 3 or 4 routers, internal routers, will they communicate with each other?
You're talking about the internal routers that are connected on the LAN, or the routers that are connected on the WAN?
Correct. On the LAN. So say in a certain site, if you have a site and you got 3 routers, and then you have got, and one of them is talking to the ISP, and the 3 of them are talking to each other internally. How will they work?
That basically is your LAN router, right?
Correct.
That is not your WAN router. So in that case, there is no point in adding it to the vManage. See, we have a LAN routers over here. We have not added it to our vManage. SD-WAN itself is software-defined wide area network. There is no point in adding your LAN routers to it. Does that answer your question?
Router can talk to our traditional routers. So if the traditional routers are, say, running OSPF or something, it will be able to communicate.
Yes. So see, we have over here, we have a router which is not managed by vManage. We have a router over here which is being managed by vManage, and we are also running OSPF over here. So we'll see how exactly this configuration is done. So on this router, just to give you a brief, on this router you will configure it via CLI, and over here you will configure it via templates using vManage. We will see how that is done. Does that answer your question?
Thanks, Roman. Yes, thank you.
Thank you. Any more questions, guys?
Yeah. I have a couple of questions actually. One is related to all are related to redundancy part only actually. One is related, suppose we have multiple vEdge actually. So in this topology, we are not able to see multiple vEdge. So in that case scenario, will the SLA come into picture? You mentioning that there is no SLA coming if the router is going down, but if suppose we have multiple vEdges actually, or will it come into picture, or will it be L3? basically routing
Yes,
OMP that
SLA will come into
take
the
care.
picture. SLA will come into the picture.
Another point was related to like we should not have any single point of failure in our like enterprise network. So in that case scenario, suppose we have we have multiple vSmart, and we'll be going through that in our later classes. But in our topology, we have single vManage and vBond actually. So is it recommended to like definitely for vManage we should have dual, or will it be working in mostly it will be working in master and slave, right? The vManage actually. vBond also can be implemented in with redundant setup.
Yeah. So it is always recommended to have two vManage. The reason we are using one vManage over here is because of the see this is hosted on GCP. Okay, we only get 32 GB of RAM on GCP. Okay. Now this itself utilizes approximately around 8 or 16 GB of RAM. Now if we add another vManage, then I mean we will not be able to do all of these labs. Apart from that, this Linux machine itself utilizes 4 GB of RAM. So there are certain limitations wherein why we are using only one vManage. In the actual environment, you will be having two vManage, two vBond, minimum of two vManage and two vBond, and both of them will be active or active standby depending upon the requirement. vBond will be active. Okay. Does it
Will you be
answer
able
your
to share
question?
some? Yes. Will you be able to share some documentation related to it, like in later classes whenever we are going through the redundancy part?
We'll do, sir. Yeah, we'll do, Santosh. Don't worry.
Thanks.
Any more queries, guys?
My final question is about the labs. Have you got a lab directly for EVNG? Yeah, not Google. If you've got a server that can take all of that, I've got quite a beefy server, so I might be able to have two vManage.
Okay, so what are the specifications of those servers?
128 gigs, 1.2 terabyte NVMe.
And how many CPU cores?
That's 20 by 56.
56 CPU cores.
Yes.
Okay, so in that case, you can build the lab on the server itself. Okay, so for that, I will have to see if we have any videos that we can provide to you. So I will check if we have any videos on how to build the server on the, or how to build the EVNG lab on the server. If we have any videos, I will share it with you.
All right. Thank you.
Thank you.
I have one question. After this,
Any more query, guys?
Yeah, hi. I have one question.
Sure, Akshay, go ahead.
Yeah, after this control connection establishment, right? So you have told that some netcom something is there, right? Can you just tell me what is, what is after that, after control connection establishment, right? So can you just explain me what are the steps? Because I joined, this is my first class, so I didn't understand that part.
I will do that. No problem. So, Akshay, just one input. Since this is your first class, maybe you'll have to go to the demo recordings and the day one lab. Okay. Now, coming to your question, this is the VH. Now it has first authenticated with the vBond. Okay. It is authenticated with the vBond. What is the role of the vBond? After the authentication, we'll share the vSmart and vBond IP with the edge router, correct?
Yeah, vSmart.
Why will it do so? Because my edge router needs to know what is the IP address of the vSmart and vBond so that it can go there and authenticate with itself, correct?
Oh, yeah.
These details will be shared under the control connections.
Yeah.
Now, my edge routers know what is the IP address of the vManage. Okay. Now,
Yes.
my vEdge will go and authenticate with the vManage. After the authentication is done, it will form one control connection. Okay. On this control connections, my role of the vManage is to push the configuration. Push configuration, and if there is any localized policy, it will also share the localized policy. Now, this is just the control connection. It has formed a tunnel. Okay. Now, it also have to push the configuration and localized policy, and that has to be done through some protocol, right? It cannot just go like anything. It has to be done via some protocol, and that is where the netconf protocol comes into the picture. Configuration and the localized policy is pushed to the edge router by vManage using netconf protocol over TCP port 830. Clear till here?
Yes. Yes, sir.
Third one. Now, let me just clear this. The third authentication is with the vSmart. My edge router will go and authenticate with the vSmart. After the authentication, it will form a control connection. Number of control connections between the edge and the vSmart depends upon the number of WAN links. If there are 2 WAN links and 1 vSmart, 2 control connections will be formed. After forming the control connections, this is my control plane. vSmart is my control plane. It is responsible for giving the routing details to the edge routers. Now, if this edge router is forming the control connection, my vSmart already has the routing details for this network. After the control connection is formed, my vSmart will share the London route details with Dubai router over OMP protocol. It will not just share the route details, it will also share if there is any centralized policy, it will push the centralized policy. Apart from that, these two routers also form a tunnel with each other. Now, to form a tunnel, there is certain IP address requirement, right? This router should know on which IP to form the control on the IPSec tunnel. Apart from that, they also share, it also has to have a key so that they can form a tunnel. Now, these all details are also shared by the vSmart. IPSec details. Now again, these details cannot be shared like anything. So it is shared over OMP protocol under the control connection that they have formed. Fair enough, Akshay?
Yeah. Yes, sir. Yeah. Thank you.
Any more queries, guys? Okay, so if we do not have any more queries, we'll wind up for today. See you all next week. Thank you, guys.